because it looks a little thin out there. Josh, and I have your exam. You send that back up to Josh. Thank you. Okay, Harrison. Am I surprised? Jean-Luc. Joe Bentley. Mark Bergson. Nathaniel. Stephen. Didn't get Stephen today. Drew. Julius. Joseph. Oh, Luke's got sick. Rachel's here. Jackson. Nicholas. Canella. Thomas. True. Let's see. Here today. John Ortman. Tavio. Alex, who's always late. Caroline. Is Caroline not here today? All right. Sarah. Okay. Keith. Didn't get Keith either. Grace. Duchette. Not here. Okay, not here either. Elaine. And Brianne. Okay. I came across an article, just came out this morning. How did the Senate end up with supermajority gridlock? So I don't know if you've been following this, but there's a big deal about the filibuster and trying to get the debt limit passed, and McConnell's saying that the Republicans aren't going to vote for an increase in the debt limit, and then they made sort of an agreement. But the question is, the filibuster, right, you require a 60% vote, so a supermajority. So this is sort of an interesting little article. How did the Senate end up with a supermajority gridlock? So I put it in the majority rule folder. And the argument is whether the Constitution allows for, this discussion here in this article is whether the Constitution allows for a supermajority, because it says that the Constitution says that for a bill to pass, you have to have a majority of both houses. And then it says, and then later on, it says that you need a 2/3 vote to overturn a presidential veto. And so it says, then it must have meant, majority must have meant 50% plus one, right? So this is, and again, this is sort of a Buchanan issue of the optimal majority. Why do you have a filibuster in the Senate, but you don't have a filibuster in the House, right? So anyway, I put that in the majority rule. Also, I got for the review session, I got lane 125. So I'll send you all out an email on that. But so I remember I switched the date from Saturday to the Thursday. So that'll be on November 4th. And again, I've got it reserved from 6 to 9. So you guys will get to decide whether you want to do the first part of that, or my 105 class will do the second part of that. Also, I changed I have in the notes, I had the notes to the game theory in the game theory section. So I switched, I just changed the title of the first one so that it's clear that it says game theory notes up to tit for tat, and then the second one is tit for tat to the end. So I just didn't, because it said before, I think it said before just game theory notes tit for tat, but it's really from the beginning up to tit for tat, okay? And those are handwritten. In the second part, they're typed up. All right. That brings us up to the idea of the prisoner's dilemma. Well, first of all, any questions on we had on the, then I handed back the exams and, all right. So I'll be in the office today, again, 1:15 to 2:15, and then tomorrow, 9 to 12. All right. This is the issue of what's called the prisoner's dilemma. Maybe I'll do. I'm the only one that brings chalk. Right? Everybody uses my chalk, but I suppose I could take it back with me, but I don't. All right. So this is the issue of prisoner's dilemma. And this is a case where you have a two-party game, and both parties, and it could be multiple parties as well, but the simple example is a two-party game where it's non-zero sum. So I could win 10 and you could win 8, rather than, you know, I win what you lose, sort of. That was a zero-sum game. So the idea is that both parties have a dominant strategy. This is what the prisoner's dilemma is. Both parties have a dominant strategy, but and that dominant strategy is to not cooperate or to cheat. But the payoff for both is greater if you cooperate. Okay? That's what a prisoner's dilemma is. I got a situation where you have a dominant strategy, and that's to cheat. And I have a dominant strategy, and that's to cheat. But we'd both be better off if we cooperated, if we played our non-dominant strategy. So the issue is, how do you get to that? So let me just draw up a little payoff matrix. And so let's say we'd have the following. We have what I'm going to do and what you're going to do. And you can do two things. You can steal or you could not steal. And for me, I'll make it so I can steal or not steal. And if we draw a little payoff matrix here, and since it's a non-zero sum game, I got to put two things down. I got to put how much you gain and how much I gain. Okay. When we had a zero sum game, I could just put 8 for me, and then you would get, you would lose 8. But with a zero sum game, normally what you do is you put the two payoffs in the corners. So we'll put 10 for me here, and we'll put 10 for you. Okay. So the way we're reading this is that if you steal and I steal, we'll both get 10. Now, if we put not steal, we'll have 12 and 8. And if we have not steal on my side, it'll be 8 and 12. And then we'll put 11 and 11. So I set this up so that both parties have a dominant strategy. And if we look at your dominant strategy and your score is here, if you steal, okay, then my score is up here. If you steal, my best strategy is to steal. If you don't steal, my best strategy is to steal, right? So if you don't steal, then excuse me, I put a not. Anybody catch that? Right. So I pointed to the wrong thing, right? Right. I just pointed to the wrong spot. So my best strategy is to steal no matter what you do, right? So if you steal, my best strategy is to steal. if you don't steal, my best strategy is to steal, right? 12 is bigger than 11, and 10 is better than 8. Now, if we look at if I steal, then what's your best strategy? Your best strategy is to steal. 10 is bigger than 8. If I don't steal, your best strategy is to steal. 12 is bigger than 11. So if we have, my dominant strategy is to steal, and your dominant strategy is to steal. And so what's the goof up? The goof up is we're going to end up there, right? Both playing our dominant strategies. But look at the payoff. The payoff is larger if we show up not stealing, right? So we have a larger payoff if we have not stealing. So that's a problem, right? That's the prisoner's dilemma. The dilemma is I got a situation where both parties have a dominant strategy to cheat and not cooperate, but we're both better off if we go ahead and we cooperate. So, question then is, how do you get to there, right? How do I get both parties to give up their dominant strategy, right? Both parties cooperate, right? Or they don't steal, and so they give up their dominant and give up your dominant strategy. Well, if you had ECON 105, we talked about Frederick Bastiat, right? 1850, and by the way, I was on WJR radio at 760 Detroit yesterday, and I quoted Bastiat and Hayek, and it's only 8-minute discussion, so everybody's driving home. Actually, a former student of mine from about 30 years ago, and he now teaches at U of M Dearborn. He was driving to, he said he was driving to work, and he heard me on WJR, and he said, talking about Bastiat and Hayek on a regular radio station might go a little over the people's heads. But anyway, it was fun. But I don't know what that had to do with anything. But both parties are going to, oh, why? Because what did Bastiat say? We form a government, right? And what Bastiat's talking about, he says, why do we form a government? We form a government, it's our natural right to self-defense. That is, to what? Protect property rights. And so we have this natural right to self-defense, so what do? We form a government. So how do we get that you guys, if I'm not going to steal your stuff, your best strategy is to go out and steal, right? But if I'm going to steal your stuff, your best strategy is to steal. But we're both better off if we run around and, market capitalism doesn't work if everybody's out there stealing, right? Again, from Econ 105, Mises is talking about how capitalism works, right? And so how do we get at this cooperation? What do? Public choice, we form a government, right? So why do we form, we were talking about, we started out, why do you form a government, what do you need government when markets are Pareto-optimal, Pareto-efficient, right? We talked about problems, externalities, public goods, okay? But another issue is I would form a government because this gets us out of this prisoner's dilemma. So you need to have somebody that's out there protecting the property rights. So what do? We give coercive authority to our government, right? We form this government, and what's it supposed to do? It enforces cooperation. So you can argue for a role of government to enforce cooperation. How many have ever read Murray Rothbard's book, For a New Liberty? Anybody? Murray Rothbard is an anarchist, right? And he doesn't believe in any government at all. And it's an interesting little book where he sort of tries to explain how you would get how you would get a protection of property rights in the absence of government. And he has interesting little stories about, well, what would happen is the insurance companies would hire private police to go out and make sure you weren't stealing stuff so that they didn't have to pay for that, A little beyond, in my view, what's likely to happen if you didn't have any government at all. And remember, Mises says that classical liberals are not anarchists. But it's interesting that, anyway, if you ever get a chance in the summer or something to take a look at the book, it's an interesting way that he comes up with things. But the bottom line is, one reason then to form government is to enforce this cooperative strategy in a situation of a prisoner's dilemma. So now the question is, okay, we got the idea that we're going to try to enforce cooperation. So the question is, then, what do you got to do? It's basically, how to enforce this, right? So we agree, okay, I'm not going to cheat, I'm not going to steal. We make this agreement, I'm not going to steal, you're not going to steal. And so the question then is, how to know if somebody cheated. Right? I got to know that you cheated in order to be able to enforce this cooperation. That is to, I got to know whether you've cheated or not. But if there's a bunch of us in the game, who's doing the cheating? Second thing is the prospect of punishment. Are you going to punish me if I cheat, right? And that brings us then, what is the degree of punishment? Right? If you cheat, do I cut your arms and legs off and throw you in a pile, right? Or do I spank you if you're if you're a 5-year-old or a 3-year-old or whatever, or do I make it so that, we're watching our grandkids right now, do we make it so, you don't get to watch your favorite TV show, right? So you got to come up with some way that, okay, Evelyn, if you cheat, then, you don't do what you're supposed to do, then what am I going to do? I'm going to make it so that you are punished, and here's what the degree of punishment is. And then the problem here is then how to punish. How do I make it so that I can actually punish you? Do I make it so that if you take Econ 472, Law and Economics, do we make it so that it's a criminal case, or is it a civil case? That is, do you go to jail if you don't cooperate, or does somebody sue you? I don't know if you've been following this case in Texas about the abortion. Anybody following that? So what's the deal? It's not criminal, right? If you perform an abortion, you don't go to jail. What happens? If you perform an abortion, what happens? Anybody know? Yeah, you can get sued, right? Somebody sues you. So that is then, it's not criminal, it's a civil case. So and the reason that they, there's questions about the reason that they did that, et cetera. So it could satisfy the U.S. Constitution, and that's all going before the courts. But the bottom line is, how are you going to punish people? If you don't want people to perform abortion, it's not going to say, you go to jail if you do that. No, somebody could sue you for up to $10,000, and so that's how you might do that. Now, if you have lots of unobserved variables about how to pick up people cheating, or if you haven't thought about things, then you might know that someone cheated. You might know someone cheated, but not who. but not who cheated. So, for example, I don't know if you've ever looked at this, but the formation of an oil cartel, right? A bunch of oil-producing companies to get together, and they agree, here's the amount of oil that we're all going to produce together, okay? And Iran's going to produce this much, and Saudi Arabia is going to produce this much, and Russia's going to produce this much, or whatever. So they get together and they form an oil cartel, and they say, okay, they're trying to what? They're trying to make it so that they're the monopolist producer, and they're going to go to where marginal revenue equals marginal cost, right? So they're going to make the price go up if it's inelastic in demand, okay? And so they say, okay, here's how much we're going to produce. What's the deal, right? So what we can do is we know that there's more oil coming out than agreed to, right? So there's more oil than agreed to, but who is cheating, right? Who's producing more than they said they would? And it turns out that cartels in general are hard to keep together because it's hard to know who's the one that's actually doing the cheating. Think about this. I don't know, again, if you're following this, but they're trying to get an agreement to what? Carbon emissions. Okay? They're trying to get this agreement. Oh, we're only going to let, I'm going to lower my carbon emissions to 50% of what it was here, and you're going to change your carbon emissions, and et cetera, right? So as a group, what are we worried about? We're worried about this externality of we're putting carbon out in the atmosphere. For each of us, it's better if you're not going to put carbon out there, I should put carbon out there. If you're going to put carbon out there, I might as well put carbon out there, okay? So what do you got? You got a prisoner's dilemma that what's going to happen? We're all going to have more fires in California, and we're going to have, more hurricanes. They're going to be more severe, and et cetera, right? So we've got this negative externality, perhaps, and so how are we going to agree on these carbon emissions? Well, what's the problem, right? How do we know who's cheating? Right? How do I know if China really reduced their carbon by 10% or whatever? How do I know that the United States reduced their carbon by 15% or whatever we agreed to? Okay? So that's a difficulty in trying to deal with issues where you have this prisoner's dilemma that my dominant strategy is to emit carbon, and your dominant strategy is to emit carbon, but we're both better off if we don't emit carbon. All right. Now, if you have a game that's played more than once, you got a better chance of cooperation. Right? You got a better chance of you cooperate. Why is that? If it's only played once, guess what's going to happen? We're going to cheat, right? If we only play the game one time, then you can't punish me if I cheat. So we have a greater incentive to cheat when a game's only played more than once. But if the game's played more than once, right? If it's more than once, then it's easier to punishment, right? Punishment becomes easier. I can now make sure that if you cheat, what's going to happen? I'm going to do something bad to you on the next turn, okay? Remember that we talked about this in log rolling, right? In log rolling, if what happens is we only have the one vote, right? You vote for my bill, and then I don't vote for your bill, right? And so, but if then tomorrow we're gonna have a bunch of votes out there tomorrow. Nobody's gonna play with you. Nobody's gonna log roll with you because you cheat. So now, if you think about it, if there's a known number of plays, right? So if you have a finite number of plays, but they're known how many, there's going to be an incentive to cheat. Let's just think about that. Suppose that we're going to have, let's say you're going to have 3 plays to the game. Okay? Now, and we're going to have, you're going to, what do you know? On the 3rd play, you know what I'm going to do, right? You know that I'm going to cheat, right? Because you can't punish me for cheating, because there's the, again, right? Because there's on the 3rd play is the end of the game, so what's going to happen? I'm going to go ahead and cheat, and you know I'm going to cheat, right? Because you're taking ECON 415, taking enough game theory that you know that I'm going to do that. So what's going to happen, right? You'll cheat on the 2nd one, right? Because you know I'm going to cheat on the 3rd one, so you might as well cheat on the 2nd one. But now what happens? I know you will cheat on the 2nd play, so I cheat on the 1st play. And so we're just back to one of those looking forward and reasoning back issues that we were first talking about in the introduction, is that, you know, I know that, you know I'm going to do this, so that affects what you're going to do in the 2nd game, and then you know what I'm going to do, and so we just go back and we just cheat from the beginning. So if you have a finite number, even if you have a, you play the game more than once, if it's a finite number of plays and you know when it ends, everybody's got an incentive to cheat on the last one, but knowing they're going to cheat on the last one, then they'll cheat on the one before, and so you'll end up with cheating. And that's what we said, that it was similar to what we were talking about log rolling, right? If you know that you're only going to have the one vote, then you have an incentive to tell me you'll vote for my bill, but you really don't vote for my bill. I vote for yours, you don't vote for mine. Now, anybody ever seen a low price guarantee? It's the deal. Maybe they don't do it so much anymore, but what they used to have is a low price guarantee. And yet there'd be this ad that would say, if you find this item for less, we'll sell it to you for 10% less than that. Right? So maybe you've seen some low price guarantee. Okay? So let's think about that. Why would you have a low price guarantee? Because what's going on is you guys have agreed to not get into a price war. Okay? Everyone has agreed. No price war. That is, I'm not going to lower my price in order to get your customers, and you're not going to lower your price in order to get my customers. So we'll keep our prices up. But how do we know when somebody's cheating? Okay? I can't go around and find every Walmart or whatever around, the country, et cetera. So what do? I say to all the customers, hey, guess what? You find it for sale somewhere else less, and now what's going to happen is I'm going to sell it for even less than that, right? So what this is an example where what's going to happen is you're going to find out who is cheating, and you have a clear and certain punishment. Right? I know what, because you've advertised, I know what your punishment is going to be, and I know that you've put it out on the, on the television or whatever, or on the radio. So I know that you've said, here's what the punishment's going to be, and you can't get out of it, right? I know that you're now going to sell it at 10% less than whatever I sell it at. So a low price guarantee can be used to enforce an agreement to keep your prices up, right? So it's again sort of something that you might not have thought about. Now another comment is the degree of punishment. How severe should the punishment be? If you make it severe enough, then you'll never have to use it, right? If you make it severe enough, no one cheats, you don't need to punish. And if you think about it, punishment is sort of expensive, right? Suppose that, anybody know how much it costs to put somebody in prison for a year? It costs about $70,000 a year, a minimum, right? To keep them in prison, okay? So we're sitting around paying our taxes to do what? To punish people. Hey, if I put you in jail for 10 years, that's expensive. If I only put you in jail for 5 years, then it's not as expensive. But more people will cheat if it's a lower punishment than if it's a higher punishment. So you got to figure out what this trade-off is going to be. When you are, in law and economics, one of the things that we talk about is that very thing. How do you decide what you're going to, again, whether you're going to have criminal law or civil law? Civil law, you just have the parties going to sue each other, right? Criminal law, then I got to put somebody in jail, okay? And then it's expensive to do that. So if you make the punishment severe enough, then what happens? No one cheats, right? So you never have to punish it. So no one ever shows up in jail, right? Because the penalty is sufficiently high that they don't do it. But it might be that if it's too severe, I don't believe you'll punish me. Right? If you say, like I said, if you had a penalty for shoplifting that was to cut people's hands off, okay, they're going to go, nobody's ever going to do that, right? So if you make the penalty too high, then the potential cheater's not going to believe that you're actually going to implement the thing, and so you don't have you don't end up being the punishment isn't going to act to keep people from not cooperating. Jim Buchanan has a nice little book called The Limits to Liberty. It's a short little book, but it's a nice little book called The Limits to Liberty. And he has a whole chapter in it where it's called The Punishment Dilemma. There's just a chapter called The Punishment Dilemma. So again, if you're looking for a paper topic, if that's something that you find interesting, go ahead and take a look at Buchanan's book. His book's only about that thick. And it's really an interesting little book on the ability to organize yourself politically. How can you create, how can you get enough liberty out there? There's limits to how much liberty that you can have, which, is sort of the opposite of what Murray Rothbard would be talking about. But anyway, so one of the things that he talks about is this punishment dilemma. So he's really saying, what should the rules, how do you set up the rules of the game when you're forming a government? And so that's really what we're talking about here, right? That is, I got this prisoner's dilemma that you guys are going to cheat, and we all have a dominant strategy to cheat. How do we make it so that we don't steal from one another? How do we make it so that we enforce contracts, right? If I do a contract, I have an incentive for, I have a sort of incentive to cheat on the contract, okay? So how do I make it, and you have an incentive to cheat on the contract. If I'm going to cheat on the contract, you should cheat. Right? If I don't cheat, you'd be better off cheating. But we're both better off if we can sign contracts and we cooperate with one another. So how do I set up the rules of the game to make it so that we will have an incentive to escape this prisoner dilemma and our contract law will work out? A guy named Robert Axelrod was thinking about this and was thinking about what sort of strategy should you play if we want to gain the most points over a series of plays. Okay, so he set up a tournament, and he set this tournament up in 1980, and he invited a bunch of people that were studying game theory to come up with strategies that you might play in a prisoner's dilemma. And what the deal was is that you had 150 plays, and you win by getting the most points. So if you sort of think about it, if the game were only played once, what would happen? You'd get the most points by cheating, but if they play again and the other party cheats, then you won't get as many points as if you both were cooperating, right? If you both cooperated, what would happen? You'd get the most total points out of the 150 games, you'd get more points. And if maybe somebody cheats on one play, then they might get more points on that particular play. But if you'll do it 150 times, what's the optimal strategy to end up with the most points? And they match all the players and see what happens. It turns out that the optimal strategy is called tit for tat. And he did this several times, this tournament several times, and it turns out that tit for tat strategy always won against any other strategy that you could pick up. You could pick, you could pick a strategy where I'm going to cheat every time, okay? Or you could have picked a strategy that I cooperate every time, no matter what you do. Or you could pick a strategy where you cooperate 3 times and then cheat twice, or da-da-da-da, right? You could have all sorts of different ways that you might do it. So how tit for tat works? Tit for tat works is you cooperate on the first play, then you do what the other person did, you do whatever the opponent did on the previous play. So if we take a look at this, so we're going to have you, and you're going to have your opponent, and you have 1, 2, 3, 4, etc. This is the plays. On the first play, what are you going to do? Well, let's let C, B cooperate, and X is that you cheat. Okay. So what do? You start out cooperating, right? And let's say your opponent starts out cooperating, and guess what? So what's going to happen? You guys are going to get more than if you had played your dominant strategy in this prisoner's dilemma, right? So we set up that little payoff matrix. I didn't sort of make those numbers up. out of the blue, right? I set the numbers up in the payoff matrix so that you get more points if you both don't play your dominant, that you both have a dominant strategy. You both get more points if you didn't have the dominant strategy, okay? So we set this thing up. Suppose you and your opponent both start out with cooperating. Then you cooperate again. Then you cooperate and they cheat. Well, then what do? You go back. And now let's say, should have made this farther up on the graph. So let's say we have 5, 6, 7, 8. So now what happens is if your opponent cheats on the third play, then what do? You cheat over here, right? But now let's say that if your opponent now has cooperated, then on the fifth play, since your opponent cooperated, you're going to cooperate. And if your opponent cooperates again, then what happens? You cooperate. If they cheat, then the next play you cheat. And let's say they cheat again, then you cheat. Okay? And let's say they cooperate, then you cooperate. So you always do what the other party did in the prior game. So why would this, yeah, Josh? Yeah. Your opponent cheated, so you're going to cheat.
But why would they cooperate?
It's just if they just happen to do that, right? I'm not saying why. I mean, their strategy, whatever their strategy is. We're talking about your strategy says you are going to do whatever the heck they did last time, and then what does that do? That makes it so that if your opponent happens to cheat, then the next time you're going to cheat. So why would this thing end up with the most total points? Okay, the more times you get this, right, the higher the total points you're going to get. Now, if they cheat and you cooperate, then they'll get more points, okay, than you did in that particular round. So the question is, why would this thing tend to win, right? There's no theory that could come up with the optimal strategy in a prisoner's dilemma played more than once, but it turns out that it works. So the question is, why does this work, right? Why does tit for tat get the most points? And if you try to think about it, why is that? One, there's clarity, right? I'm going to figure out, if we play this, once we're in the 30th play, and I've been watching what you're doing, it's going to be clear to me, whenever I cooperate, you cooperate the next time, right? And whenever I cheat, you cheat the next time, right? Like Arthur Laffer says, right? It ain't rocket surgery here. This is not a difficult thing to figure out. So that makes it clear to your opponent what you're going to do. The second thing is it rewards cooperative behavior. Right? You cooperate, I'm going to cooperate. And it's pretty clear. I've got this clear strategy. I'm basically telling you, you know what? If you cooperate, I'm going to cooperate. It punishes non-cooperative. That is, you cheat, I punish you by cheating. But it's also forgiving. You cheat on the 5th round, but then you start cooperating, I'm going to forgive you, right? I don't just punish you every time, from round 5 to round 150 by cheating because you happen to cheat on round 4, right? So if you sort of think through this, why would this thing be the strategy that comes up with the most total points? That is, it results in the most cooperation over time because it's got these characteristics, right? Pretty clear. I'm telling my opponent what's going to do. They can figure this out. rewards cooperative behavior and punishes non-cooperative, and it forgives you if you go ahead and start cooperating. One last quick point on this is that you can see that it has a problem if there's a if you misperceive. If you misperceive, you think they cheated, but they really cooperated. If that happens, then let's say you have CC, and what happens is they really cooperated, but you think that they cheated and they really didn't. They really cooperated. Well, then what's going to happen? You're going to cheat, and then if both parties are playing, then what's going to happen is you don't have a mechanism to get out of it, right? Because what's going to happen is that if you've misperceived, then what's going to happen, they're going to do what you did, but then you end up with a moving back and forth. You don't get to where they both cooperate, okay? So it's just an issue that if you get a misperception, how can you get back to cooperate? Once you've misperceived, and if both parties are playing tit for tat, you're going to get this back and forth every time, and you're not going to get to a CC unless there's another misperception along the way. All right, we'll finish up this prisoner's dilemma for next time, and then we're going to do chapter 7. Right, so this was chapter 4. We're going to do chapter 7, which is a mixed strategy. And the deal was that, remember, one of the things that the strategies that when we first started talking about at the introduction was to mix up your plays. Okay, it'll turn out that mixing your plays may be better than playing a dominant strategy, and we'll sort of, we'll deal with that. So anyway, so take a look at the section now. We just finished tit for tat. In the lecture notes, I have tit for tat to the end.